classes, arrays, and loops, objects, and how to control them. In this video, we're going to look at all three so that we can deepen our understanding of the concept of using objects when programming. Now, classes are a blueprint for an object. So each class will then have instances of that class. So each time we have a class, we can put one or more instances of that class into our program, and each instance will contain its own unique properties and methods. So they all will share the same blueprint for making those. Much like as people, our blueprint says we get to have two eyes, but those eyes can be of different color, or that we have hair, but the hair will be of different color, or that we have height, but our height will be different. And at any given point in time, we have a location. That location is unique to each and every person. So if we think of a class as it's the blueprint for creating an object, but that object will have its own unique value. So a class usually contains properties, a constructor, and methods. So some properties will be location, size, speed, color, visible, active, and any other properties that are necessary for taking care of that particular object. And the constructor will assign values to each of those properties. So the constructor is where we assign those initial settings that then can be changed or modified as our program runs. So the methods are actions. They are what our class knows how to do. Working with a program similar to what we used in the last video, where we have a basic object moving around on screen, so we can see it bounces off of the margins, and it's good to go. Before we continue forward into turning this object into a class, I do want to introduce an additional piece of programming concept. So if we look here under x, we're saying if x is greater than, if that x is greater than the width minus 50, do this. If x is less than 50, do this. And both of those are the same thing. Well, that's redundancy, and we always try to avoid being redundant when we are writing code. And since both of those situations we are testing for and then we're doing the same action, and because both, it's impossible to be at either the left or the right margin at the same time, what we really can say is if x is greater than the width, or if x is less than 50, I'm simplifying, it's greater than or equal to, then we want to multiply our speed x by -1. Inside programming, we have an option to use the vertical pipe. It's above the return key on the keyboard. So if x is greater than or equal to width minus 50, or x is less than or equal to 50, then we want to multiply speed x by -1, thus inverting our direction of travel. So we can simplify what we're writing by using the double pipes, and we read that as the word or. So what that means is if this situation or if this situation is true, it only has to be one of them, and we know they can't both be true at the same time, then we're going to multiply by -1. And we'll do the same thing under our y options like this. So if y is greater than or equal to height minus 50, or if y is less than or equal to 50, then we multiply our speed y by -1. So that's just a little optimization that we're doing to simplify things. Now what I want to do is I want to turn this face, the smiley face, into a object so that I can add more than one of this object to my screen. So I want to be able to have any number of objects to do that. And the way that we accomplish that is we will create a class, an object class. To do that, I can simply go New Tab, and it asks me for a name for this file, and I will call this Face. And we'll see it added that there. Looking in the project folder, I will see it even added a second .pde file. So it's adding this file to my project folder. So now I have two files within that, which is why it's even more important when you are moving your project around or sharing it. You need to zip the parent folder, the project folder. That's what you zip, not the individual file. So that's important to keep track of. Now, to make a class, we simply start out with the keyword class. Kind of makes sense as we do that. Now, something else to keep in mind, classes by convention are in capital letters. So we will put that into capital letters as we type it. Then I do curly brace, hit return twice, close curly brace. Now, I'm going to put some comments in here, and this will be my properties that we will define in a moment. Then we will define the constructor, and finally we will define the methods. So every class has these three parts to it: the properties, the constructor, and the method. Now, our face class, as we are working with it, if I look here, I see that there are 4 values that we're using with that object right now: location values and speed values. So I am going to copy those, go over here, and just simply paste it in. And use auto format, Command or Control T, to clean up my indents. We should always try and clean up our indents. Now, the constructor format, we list the name of the file, or the class, parentheses, curly brace, hit return twice, close curly brace, up arrow once. So now we're in good shape there. And now we get to set our X value. And X can be whatever we want. I mean, if we want, we'll just leave it what it was before. And why retype if I don't have to? I'll just copy those, paste it in here, auto format to clean up my indents. So the constructor assigns values to the properties inside our class. Now, methods are what the object knows how to do. And a common method with visual objects, we will define it out, and we will say we want to have a couple methods that we'll work with. Void update. So this is where we will update any changing properties. And then we will have void display. And this is where we will include the display information to go along with the object. Going back into my main program, we'll see this is display information, moving here, as well as checking boundaries. That seems to be a little bit more along lines of updating information. But check boundaries is something that, because this object is bouncing off the margins, we could even put in a void check bounds. And using these different functions as a way to organize our code will make our code significantly more human readable, but also easier to debug. We're not going to struggle so much trying to figure out where is a problem when a problem occurs in our project. So now I will copy this move information over here, and we will put that under update. And check bounds. Don't really need that comment since that's already defined right there. Paste that in. Auto format. Okay, so far so good, except we haven't defined display. So let's see display here. We can go grab the face and the eyes. Let's go grab that. put that in, auto format. I'm going to just put some extra returns in here to space it out a little bit so it's easier to read, so we can see what's there. So once again, properties, constructor, methods. Inside our methods, I have update, display, and then any other methods that I am going to write as part of this project. Now going back into the main program, what I can do is I can take all of this and delete it. Or, for the time being, I'm just going to comment all of that out. Oh no, we'll leave the background line in there. Comment all of this out, because we're not using it. We're just going to we'll come back to it in a little bit. So if I want to now use this class that I've created, what I do is I say face, the name of the class, and then I'm just going to call it F right now. Then inside my setup, I'll say F is going to be equal to new face, just like that. That's it. Now inside update, f.update. So what we're doing is we are telling this object to call its update method. We will tell it to call its display method. And then we will tell it to call its checking bounds method. And even to, might as well, let's just get rid of that. We don't even need those there. Let's feel brave in our coding. So if we look at our program, I have a face object, and then I say F is a new face, dot update, display, and check bounds. Now if we run it, it should appear exactly as it did before. And that's pretty cool. But what if we say face F2, face F3? Okay, F2 is going to be equal to a new face, and F3 will be equal to a new face. F2.update, F2.display, F2.checkbounds, F3. Now, of course, I could have used copy pasting to speed this up, but I'm trying to prove a point here, which is anytime we get beyond a single instance of an object, we may want to come up with a different strategy, and that's why we will be looking at using arrays and loops in the very, very near future. Now, if I save this and run it, we should see no change, because all three faces have the same starting point, the same speed. Cool part about processing is we have random. Now random allows us to choose a random number or a range within a number. So let's say I wanted to go between speed x of 4, 10. That will give me a random number between 4 and 10. And then we'll do the same thing for y, 4, 10. So that, oh, get rid of the F there. And now when I run this, I will see they all started at the same spot, but each one has a unique value. Each is tracking when it runs into the boundaries. So it's bouncing. It's not making a global speed x or a global speed y change that would affect the other objects. So it's only affecting the individual object. So now, once again, if I want a range here on my x's, random, and if I want I need to make sure that my value is going to be bigger than 20 or bigger than 50 and less than width minus 50. So I'm just going to put it a little bit more center and say 100, comma, width minus 100. Now I'm using width there instead of hard coding in a value, which would be 700, because if I change the size of my sketch, this code still works. I could have coded 700, but if I decide I want my sketch to be 900 or 1200 or 600, if I made it 600 but I'd coded 700 in the class, then I would break it because objects could potentially land off screen. And I'll do the same thing on the height. So now they don't start in the same spot. They move differently. They all have different speeds. Play again. You can see one is going slower, the other two are fast. The previous play, all three objects seem to be on a slow speed. So you never know what you're going to get when you choose a random number. That's the beauty of working with random numbers.